Let's take a look at key eviction in Memorystore. Now that we have covered the different services, tiers, and use cases for Memorystore, we need to understand what happens when your instance hits its capacity limits. Key eviction occurs when the system runs out of physical memory and begins to delete existing data to make room for new incoming write requests. This ensures the database stays available for new data, but it obviously comes at the cost of losing older information that was already stored. How exactly the system chooses which data to drop is determined by the eviction policy. You can configure different policies depending on whether you want to prioritize removing the oldest keys or those that are used the least frequently. If you want to avoid the eviction process entirely, you need to provision enough memory to handle your total data volume. Let's walk through an example of how this looks in practice, starting with an undersized memory instance. In this first state, we have a specific memory capacity that is currently too small for the workload. Because the space is limited, the memory utilization is nearly at its peak. When the bar reaches the top like this, the system is forced into a state of key eviction where it must drop data to keep functioning. To fix this, we can increase the memory capacity of the instance. As the available space grows, the memory utilization percentage drops, and the system transitions into a state of no key eviction. This ensures that all data stays in memory until it naturally expires or is manually deleted. This is exactly the type of scenario that could show up on the exam, requiring you to understand the relationship between scaling and key eviction under high load. And that's it for this lesson.